particle moves along the x-axis, so its position at time t greater than 0 is given by x of t. Now, notice, that's just the first value. That's the original function. They call it x of t. And then they give us dx dt. This is the same thing as the derivative of the position. Well, wait a minute. They give me the derivative of position. What is the same thing as the derivative of the position function? Velocity. This is the equation for velocity right here. So they give us the velocity equation, and then they are asking us, what is the acceleration of the particle is 0. Remember, is your equal sign. So they're saying, find the t value when the acceleration is 0. Is equal to 0. Well, what do? If I have velocity, I have to take the derivative of this. So I'm going to use the power rule. We're going to take the derivative. Let's call this a of t. Is negative 40 t to the third plus 18 t plus 8. And then they're saying the acceleration is 0. So now I'm going to set the acceleration equal to 0. And now we just have to grab our calculator to solve. And you can kind of tell by the answers that this is a calculator problem. I probably should have let you know that ahead of time. But we are going to be using your calculators today quite a bit. So get those ready. And what I want you to do is we need to graph, put this into y equals. Okay, I think I got it. I wish I could make this bigger. I don't know how. Oh, that's a little better. So then hit graph. Now, I don't know where my window's at here at all, but I don't really care because all I need to do is find this one spot where it crosses the 0. So hopefully we remember how to do that. Go second, calc, which is the trace button. And then you're going to go to option 2, which is 0. And this is going to ask you to do the left round, right bound. So what I usually do is take my cursor and bring it to the spot where I get it as close as possible to that 0. And then I have to be to the left of it. So here the left is above it. I'll hit enter. And then the right bound would be below it in this case. So I'll hit enter again. Whenever it says guess, hit enter. And there it is. So I think this allows me to grab it. Sweet. And you can see the spot at which it crosses 0. Or notice my scientific notation, by the way. I hope you guys are all really comfortable with if your calculator ever gives you this e value, you know that you're not ever writing that as an answer. It's saying that's 0. Okay? But we're looking for the time value. When is t going to give you that 0 at 0.831? So option B. Alright, so kind of a good review, just talking about derivatives, and even though they give you a differential equation here, you still want to think about what's the meaning of it. Why did they give that to me? And what does it mean, and how do we use it? Okay, so we are starting our very last unit of calculus. We're going to spend about 2 weeks, maybe 3 in this unit, and then all that time after is preparing for the AP test. Okay? So, the nice thing is this takes this big idea of area that we've already understood and just keeps applying it. So, I don't want you to write anything else on this slide. Just write the title. This slide is meant to just help you frame your thinking and kind of review what we've learned so far. So what do we already know? We know that to find the area, and that's the key part, right? To find the area between a function and the x-axis, all we need to do is to integrate that function over the given x interval, right? So let's look at this visually. What if I told you to find the area under the curve from, I think that's -2 here, -2 all the way to +4. How do we find that area? Well, calculus. Calculus, that yellow area is the integral. And how do we start? We go from the lower bound to the upper bound. So, what I'd like you to do is let's try this in our calculator. And did you get this answer? Now, I will make one point. Notice it's a sine function. Double check right now. Is your calculator in radians mode? Okay. And then I'll just walk you through it because it's pretty important that we know how to enter this into our calculator. So, if you're not sure, let me walk you through what we got going on. I'm going to just do this, go to a blank screen, and first thing I'm going to do is check my mode. Where is my mode? Oh, it's right there. So I notice that mode, you can see there my radians already highlighted, so I'm good. Then I'll go back to the screen. Now you have multiple options. The one I would choose is hit the math button, and we're going to go down to option 9. That's the finite integral. And those of you in class with me today, if you don't have this appear, let me know and I might be able to change it so it looks like that. It depends on your calculator. If not, I will show you how we enter it in anyways. So, but what we're going to do is we're going to type in the lower bound, -2, to the upper bound, which is 4. And then we're going to type in the equation, which I forgot. So I'm going to show you guys a screen. Why don't you go ahead and type that in. Be very careful with parentheses, because my calculator provides parentheses when I typed in sine of x. Nope, the plus one is after the sine of x. So you have to do, your calculator will give you this green parentheses, so you have to finish it there and then put the +1. And if all is done correctly, you should get the same answer that is up there. Okay. Now, what if you don't have this model, the TI-84? What if you have the TI-83? And what if you can't change the operating system so it looks like this? I can show you. I got to change. You guys don't have to do this. I just have to go to Classic. And let me hit Enter. And I'll show you how this is typed in. So, if you have the TI-83, you know what? Let me steal this on a separate screen. I'll make it much bigger. Okay, so look at how you have to enter this. If you have a TI-83 calculator, you still do math 9, you get F in, and then it starts you with that parentheses. So what do we always type? We type in the equation, and then you have to do the comma, which I believe is just above the 7 button. So there's a comma. And then you will always type in x. This is like our dx. So this will always be x. And then there's another comma. And then the last two pieces are the bounds. So you're going to type in your lower bound, comma, and then your upper bound. Okay. So if you have like a really old school calculator like this, these can't be changed over to the newer operating system, but if you have like an updated version of that, I should be able to switch that no problem, which is super friendly because this is kind of a pain to enter all that in. But if you didn't get this answer, I would check two things. First thing I check is, are you in radians mode? Second thing I checked is, did you type it in correctly with the parentheses? So, when you are allowed to use your calculator, you don't have to show any work other than this right here. Okay, now that's very important, because if this was a calculus free response question, they're going to look to see that you show the integral set up. You don't show any other work, and you write your answer, and that's it. But if you just type it into your calculator and you just have the answer, they're not going to give you credit for this. So that's the part where you have to be more diligent with the work that you show. Okay? So that's our goal today. However, we already know how to find the area underneath the curve between the x-axis and the curve itself. Right? So we already know that. But how do we find the area between two curves? Okay? So how would I find the area between a blue curve and a green curve? How do I find that red area? Think about that quickly and just see what you would do to set that up. What is it? Subtract them. Perfect. It's exactly what you would do. Now, watch. I'm going to add a little bit to our diagram here, but look at what we know. If I know the blue curve has all that area, right? Let me just pull that out. This is the area of f of x. And then I know that the area from the green is all of this. If I subtract the two, what's left over is the area in between. And that's exactly what we're doing. So the only thing we're going to do is, I'm going to write this down here, to find the area of the red shaded region, we're going to take, and again, remember area is the integral, we're going to take the integral of f of x. Now you can do this one separately. You can put f of x dx, but we also know that we could join them together. And we're just going to subtract. So that's a visualization of exactly what we're doing. Okay? Here's what I would do if I were you to write notes. I wouldn't write any of this unless you really like the visualization piece. I would write this last thing that I'm going to write down. The area, let's say area between. That's all we're doing. What's your top function? That's the f of x minus the bottom function. Now I will mention that everything we do today is with respect to the x-axis. Okay? Tomorrow or Wednesday, we're going to switch how we view that. So hopefully you're going to become really comfortable with today's work. And I will mention a lot of what we do this unit is really building on what we did the prior lesson. So what I mean by that is if you don't do one night's homework, it could really cause confusion moving forward. So I think it's more important this unit than more than any other unit is stay very current with your homework. Okay? All right. Now, don't write this, but look at here. What if I have two functions, but one goes on top of the other one at some point? So what if things are a little bit more funky? We still take this idea of area between the curves is the top minus the bottom. However, at some point, the top and bottom switch. All that means is we have to set up two different intervals. So look at the division here. If I look at the spot from A to B, you can clearly see that there's a top here and a bottom here. So we're going to set that area up first. So what is the first area from A to B? And then which function is on top here? It's the blue f of x minus the green g of x dx. Plus. Now we're going to do, and that'll give us this area of this first unit. Now I have to do the second piece. And the second piece goes from B to C, but this time g of x is on top versus the bottom is f of x. And of course, so, if you see this, that just means you have to set up two different intervals. And that's it. Okay? Now, the important thing, what if you don't have a graph? Okay? How do we do this if we don't have a graph? There's ways around it, but if we have the graph, it makes it so much easier. Okay, this one, we are going to set up the expression and solve without using a calculator. So we do keep in mind that there are times, a lot of times, that you're going to be asked to do problems like this without a calculator. Now, actually, this one, I could not even give you the graph. Right? This is probably what the question would look like. Where it says, find the area between the curves bounded by the following. You have a y value, and then you've got two x's. So what we need to do is we need to create a very rough sketch. It does not have to be super accurate. Okay, so here's what I would do. And I have a much better graph, but if I were you, I would draw a rough sketch that looks like this. And I would say, okay, well, what do we know? When x is 1 and x is 3, those are kind of my bounds right now. So I'm not sure where that's going to come into play yet. But I know that those are my kind of cutoffs in the x direction. I also know that I've got a linear equation that has a y-intercept at -2. So 1, 2. Again, this doesn't have to be perfect. So I got y-intercept at -3, and its slope is +2. So I'm going to put it down here. I'll go up 2 over 1, up 2 over 1 roughly, up 2 over 1. I'm just going to draw a rather poor sketch. We know what that graph is. And then I've got a parabola that is way down here. It's got a y-intercept at -13, and it's opening downward. So if I was to really go crazy with this, I know I'd be somewhere down here. And then I know that my parabola is going to probably look something like that. Okay. Again, if you're not sure and you're allowed to use a calculator, then you would graph that. But all we care about is the fact that now I know which value is on top. And if you're not really positive in this graph, you could do this. You plug -1 into the blue equation and -1 into the red, and you would see which one is higher. The blue one will have a higher output. You could plug in 3 into each equation and also see that the blue one is higher than the red. Okay? But there's my graph. You can see my sketch is not nearly as accurate as the actual graph, but that's okay. We don't need an accurate graph. They're going to give you 0 points for this graph. Right? All you're going to do now is take the idea of what is the area. So why don't you do that? And we're going to do this by hand, but I want you to see if you can just set up the correct integral right now for this image. So hopefully you're thinking, all right, well, what are my bounds? What's the lowest x value that I have? And that's the positive 1. And then where's the next x value? That's at 3. And then you're going to do the upper bound minus the lower bound. Or excuse me, the upper function or the top minus the bottom. And I should have really emphasized this, but if you do not put parentheses around that, then it is definitely wrong. And I'll show you why, or maybe you already see why. So, if you wrote this without the parentheses right now, it would not be correct. Because this negative, the red negative, is going to be distributed as we go in and solve this. So now, we have to simplify the inner part of the integral first, before we do any work. I'm going to distribute the negative. And then I've combined any like terms. I like to write this in a better standard form. So I'm going to put the x squared term first, and then I'll have a negative 6x and a positive 10. And now, all it is the same thing we've been doing for the past 2 units. Now we just have to do that integral by hand. Upper bound minus lower bound, take the antiderivative. So I'll let you guys do that. I'm going to work through it as well. If you want to follow along with me, you can. Otherwise, go ahead and do it on your own. You need to take the antiderivatives. So I'll get 1/3 x to the third minus, here I'm going to say if I put a square here, that 6 is going to be divided by 2, so it'll be a minus 3 plus 10x. And then we have to evaluate from the upper bound minus the lower bound. And 7 divided by 3 is 9. 7, 30. That whole thing is 12. Of course, they have to have a fraction in there. I got 14/3. I'm going to check using my calculator just to see that I didn't make any small mistakes. And hopefully you guys can do that as well. Now what I would do, I guess it's up to you. If you trust your algebra, you can take this one right here and plug that into your calculator. Or if you don't trust your algebra and you know that you're going to use parentheses correctly, you can take the very first one and plug that in as well. But try one of the two. So grab your calculator, hit Math 9. I'll show you what I got. So I trusted my algebra, plugged in this one. I got 4.66 repeating. What I want to do then, just to make sure that it matches, is I'm going to go to the math button, option 1 is fraction, and 14/3. Those of you that have the TI-83s, let me just show you what that would look like if I did that using your method. Oh, shoot. Let's try it again. Oh. I think this is... No, okay. I don't think it's going to give it to me. But I can type it out. So if you're doing this part in your calculator, it would be finite integral, and then you type in the equation first, followed by the comma. Then you'd have to have x, because that x is like our dx. And then you'd have to put the lower bound, comma, upper bound, parentheses. And that should be in the TI-83 format. Okay, so that's really the basics of today. However, as we know in calculus, problems get trickier, right? And that's what we're going to explore for the rest of this. Some of it we're going to do by hand. Some of it we're going to do just with our calculator. And my goal is to have you guys do this without, first without a calculator, just so we get really confident in it. Plus, it helps review our integrals. So let's give you another scenario. Find the area between y equals x, y equals 1 over x squared, and x equals 2. So the first part then is, how do we get a graph? What if I can't use my calculator and I don't remember what the graph of 1 over x squared looks like? So here's what I would do. I'd start with the first equation, y equals x. Well, that's just a linear equation with the slope of up 1 over 1, up 1 over 1, up 1 over 1. So I would just draw a nice linear equation. And I do know the line x equals 2 as well. I usually put those in dotted lines because when x is 2, it'll give me that vertical line up like this. So I know those pieces, but what about the line 1 over x squared? So this is the spot. Let's do that in green. First, I would write it like this. And then I would notice that it's going to be somewhere when x is 0, 1, 2, 3, 4. So let's make a quick little table just to check those points. And eventually you're going to notice the pattern of this graph, and then you'll be able to go. So when x is 0, that's undefined. Right? I can't plug 0 in and go 1 divided by 0. So I know that it's undefined at 0. So there's some type of asymptote there, probably a vertical asymptote here. But when x is 1, 1 over 1 squared is 1. So over 1 up 1. There's my first point. And when x is 2, that's going to give me 1/4. So I'll go up 1/4. And you can notice the pattern here. If I plug in 3, I'll get 1/9. If I plug in 4, I'll get 1/16. So you can kind of really see where that's going. Which means, since we know it's undefined, you basically know this graph right here. The only thing I might suggest is, let's try 1/2. just so we know kind of roughly where this is going, if I put 1 over 1/2, now we have to be careful. That's 1 over 1/4 when I square everything, and then we multiply by the reciprocal, which basically is 4. When I go over 1/2, I'm up here at 4. And there's your nice function. Now, we have to find the area between all of that. Well, what is that? It has to be below the blue, above the green, and then to the left of the red. So it's all of this right here. That's what my area is. Now you can definitely tell I still have a top function. The green part is the bottom. And then I have my bounds. We're bounded by 1 to 2. So why don't you, right now, I want you to set up the integral. What does that look like? And then we are going to do this by hand. And then we'll use our calculator to check. We got that. Top function is the blue linear equation, y equals x. Bottom function is the 1 over x squared, and then we're subtracting. Now here we don't have any algebra or any like terms. The only thing I would do is I don't love the way that this part is written. If I'm going to take an antiderivative, I'm going to rewrite that so it's x to the negative 2. And I invite you guys to go ahead and evaluate the integral with how to calculate it. And if you get done, go ahead and check it with your calculator. Doing it by hand. Remember, there's always a 1 there. And here we've got undoing the power rule, so I'm going to add 1. So I get x squared, so 1/2 has to go in front. I'm going to add 1 as well. And when I do that, I get a negative 1 up top, which means I could kind of divide by a negative 1, or just put a negative 1 up front. That's going to turn this into addition. And then we will evaluate from 2 to 1. So I might clean this up just so it looks a little nicer. And now we have to plug in 2. And then we are going to subtract. And remember, you are thinking about that as the top minus the bottom, or the upper limit minus the lower limit. squared is 4, half of 4 is 2. 2 to the 1/2 power, 2 to the -1 is 1 over 2 or 1/2. So then I've got 2 plus 1/2. I think of this as really 4 over 2, so that'll give me 5/2 in that first part. And then here, we end up with 1/2 plus 1 over 1, or just 1, so that's 3/2. And 5/2 minus 3/2 is 2/2, or 1. And if you check that on your calculator, here's the TI-83 way, here's the older way, or the newer way, I should say. And it confirms we get 1 either way. So hopefully you can kind of see why this is our last unit. We are building upon our skills from all the other units. Oh, you're good. Yep. Thank you. Yeah, no problem. All right. So let's see. I believe the other questions that we have today are no calculator. So you might not have a lot to write down for the next couple pieces. I do remember I want to steal this graph, if it'll let me. All right. This one, maybe you just don't write. Okay, let's just grab our calculator and do it. I want to do this as fast as possible since we only got 15 minutes left. What if I take that same graph? Oh, look, I already put it on there. Exact same thing, except for now we say we're also bounded by the x-axis. So that's a little bit of a change. Okay, we still have all the other lines, but now we have to be bounded by the x-axis as well. That means I'm going to be below the line here. I'm going to be below the red line, and then we're cut off at 2. So I just have to find this one. Well, what we would do is just set up. Sorry. Let's hope that this is a little better. So we need to set up the area. And again, this would just be grab your calculator. Now, what work would you have to show if this was a test question, but you're allowed to use a calculator? You'd have to show the integral setup. So look at our bounds. Well, what's our first bound? Where is the lower bound going to be? 0. Right there at 0. Where's the upper bound? 2. And then what's the first equation? It's a little bit different, right? This we have to be careful because on this part, my top equation is the blue one, which we know is x squared. Actually, this is not 100% correct because we can't do the full integral from 0 to 2. Right? The problem is I've got 2 different tops. So what I need to do is I need to split this up. And I need to split it up not from 0 to 2, but we got to go from 0 to 1 first. So I need to find this area first, from 0 to 1, with the top, which is just x. Now notice, that's just a regular integral, right? That doesn't have a bottom, or bottom is the x-axis, so we can just leave it right there. Plus, the integral from 1 to 2. And now 1 to 2 has the area under the curve of just the red piece, which is 1 over x squared dx. You see how that's different than the problem we just did? And the whole reason why is because my tops are different. And when that happens, you have to split this up into 2 different areas you have to find. And then why don't you do this in your calculator? You could actually type it all in at once. You'd have to do this integral first, hit plus, and then do math 9 again to set up the second integral. But just go ahead and try that and see if you can get this to work out. What'd you get? So that's the only work you need to show. What I've experienced in the past is students, for a problem like this, they just write the answer. And I would hate to take away points or for you to lose points by not showing exactly what you know. Okay? Alright, let's see. I'm not sure if we'll get through all of these. That's a fun one. We definitely want to get to this one. So let's jump here. So this is a delta math problem, which your homework tonight is delta math, which is good because I think this is something that getting that immediate feedback is perfect. So what do they give us? They give us the two functions, f and g, and they tell us we're bounded by the x-axis. Find the area using a calculator. Now notice, I don't love the rounding here. Like I would want more accurate answers, but they say round to the nearest thousand, so you do have to round accurately. Now for this problem, there's two different ways you can do it. Okay? You can definitely see your bounds here. Okay? Here's one. We've got this point, and we've got this point. Now, we don't know where this spot is. And you can't guess. You have to find that using the intersection piece on your calculator. So, what I'd like you to do right now is grab your calculator. I want you to type these two equations into y equals. And we're just going to find that intersection point right away. So we'll go y equals, type in the two equations. And then you can hit graph. You might have to adjust your window. Alright, so let me show you what I got. So that's all I need. I just need to find this intersection point. How do we do that? Just a quick refresher. Second, trace. Anytime you want to find something on a graph, it's under the calc feature. And then I want to go to intersect, which is option 5. Hit enter. And then what I usually do is just scroll until I get that cursor to go to the point where I want it. And as long as it's close, you're good. And then it says first curve, hit enter. Second curve, hit enter. Take a guess, hit enter. And there it is. There's my intersection point. So I need to record that so I know exactly where that spot is. So I know that this spot, and it's really, for our sake right now, it's the x value that's important. It's my advice to take all of that number. Don't round intermittently, meaning don't round, you should only round using your final answer. I'm pretty sure we don't need the y value on this piece, but it's there in case we need it. Okay, so, don't need that part. Now, that's important because my first method, here's how I would do the first method. Method 1 would be, let's draw a line right here because I also need to find this spot on my calculator as well, but I can find an area between this curve right here. Right? So I can find the blue area, and then I can find this area as well, and I can add those together. So let's go back to our calculator, and this time we got to find the 0. So I need to find this blue spot right here. Where does that cross the x-axis? Go second calc. We're going to go to 0 this time. And then I got to make sure that I'm on the blue equation. And I need the left bound, which is above the x-axis in this case. I need a right bound, which is below. Take a guess. And there's my 0. Now notice, it's not 3. If you guessed 3, Delta Math wouldn't give it to you. Okay? And neither would any calculus test. So this is really testing your calculator. But this point is at 2.92214. 4, 0. Now, I should do the same thing right here. I should do the same thing right here and find, oh, sorry, this 0. However, this is linear, right? So you could probably do that pretty quickly by making this 0 and solving. If I add the x over to this side, you know very nicely that this is at 8. Okay? If you didn't, then you would just have to use your calculator and find it. Okay. So I don't need this. But I do know that this is not 8 times 0. Oh, okay. So, method 1 would be setting up the integral from the blue area, which is starting at 1.66. I miss working at home for this reason. So we're going to go from this x value to the 0 here. And then we got to take the upper bound, which is the red linear equation. So that was the negative x plus 8. And I just would recommend throwing parentheses on that. The top minus the bottom function. And what's the bottom function? That's the parabola for this part. So now this answer will just give you this area. But we want the full piece, so now you have to add the integral from this x value all the way to 8, but notice it's just got one top and it's bounded by the x-axis. So you go from 2.9221444 to 8 of what is the top. All that is the linear function, and those are your two pieces that you would add together. teaches it a different way. I think that is the best way. And by the way, you could do that in your calculator. I do want to show you one last method, and I might not get all the way through this, but that didn't work the way I wanted it to. What's another way to break this up? Watch this way. What if I took the area under this curve here? So I took the area from 1.6